All right, 4.4a, graphing trig functions. Let's talk about graphing trig functions, how to use the equations of the sine and cosine curves, and we'll identify the amplitude and period of and how they affect a graph. We'll talk about that as we kind of roll in here today. So we'll kind of break this section into a couple pieces as well. So sinusoidal functions, fun to say there. So this is where we have a transformation of a graph, but it's transformation of the sine function. And the cosine function is a horizontal translation of the sine function. So when you look at those graphs, you'll see the cosine is just kind of like a horizontal shift. We'll notice that. We'll point that out with the graphs as we go. So the general form of the sinusoidal functions of sine and cosine are as follows. You've got this piece here. So write that down. Y equals a sine, a times a sine of bx plus c plus d. And then cosine would be the same thing. You're just going to substitute cosine in there instead. A times cosine of bx plus c in parentheses plus d. All right, a, b, and c and d are all constants, and a and b can't be zero. So all of these things in here, a, b, c, d, those are all constants. A and b can't be zero. Talked about that. So these are all going to be numbers that you plug in, and what they'll do different things to your graph. Okay. So let's get to the basics of it. A periodic function. So a function is called periodic if there's a number a such that f of x plus a for all x in the domain of function, it repeats over and over. Basically, that's all that's saying is that it's a period if it repeats over and over again, like the sine curve does and like the cosine curve does. So a period, we could say, is one complete pattern of the graph. One complete pattern of the graph. So where it's going to start, it's going to stop at the same place, and then it's going to repeat over and over again after that. And in these things, in general, your period is going to be about 360 degrees or 2 pi, okay? In general. There are some things that will change the amount of the period, so it'll stretch it vertically or horizontally and make it a larger or smaller distance before we start to repeat again. Okay, so let's talk about the basic sine curve, and this one begins at 0, 0. So we'll just kind of talk about that here really quick and say, I'm just going to put an arrow here on this part, on this graph. All right, so we know that it begins at 0, 0. So we're going to have we'll do sine in blue, I guess. And it's going to start here at 0, 0. We know that. Okay, so when we label these axes, though, we're going to kind of label them as, pi and 2 pi and half pi if you wanted to. But we know that we've got a period of 360 degrees. So if each of these things is, say, half a pi, so if this is pi over 2 and this is pi, then, and this would be 2 pi or 360 degrees, okay? If that's what we're looking at there, that's kind of what we're trying to see. Okay, so the graph should start repeating after that. So what happens is it's going to go as high as 1 as the graph goes up. Okay, and we'll point some things out, but the graph's going to look kind of like this. It's going to kind of go up towards 1, and at about 90 degrees, we should say, or pi over 2, right? It's going to be at 1, and it's going to curve down. And at pi, it's going to go through the x-axis again. And then it's going to come down here and be at like -1. Should be a nice smooth curve. Mine's got a little bit of problems to it. And then I'll just keep doing that. Down here, it should kind of curve down and be about -1 here when you get to the next, about 270 degrees or so. And then it'll start to curve up again, and then it's going to go right through the axis here at 2 pi. Okay? So what you'll see is that's the piece. That's one period. We start here and we kind of go from this part to this part is one period. Now we're going to keep going. It's going to keep repeating on and on and on from there. So for instance, it would keep going in this direction down here and start to curve, but then it's going to do the same thing as we keep going over here, okay? And it's going to come back down through and back up and so on and so forth in this direction, okay? So you notice again, there's another period right here, right? Because it's going to look the same, all right? So a couple things to point out though on this one is that just kind of get an idea, think about sine being your y values, right? So if we think about sine and, you know, there are y values when we do our trig ratios, right? So let's think about where you're at y value here. Well, when you start out, you're at 0. So at 0 degrees, you're at 0. And then as you go up, right, this is pi over 2, which is also 90 degrees. So at 90 degrees, you're at basically at 1, right? You're going to be up here at 1, okay? Then at 180 degrees, you're back down to 0 because you go through here. At 270, you actually go back down to all the way down to -1 when we get down here. So it'll be 270 degrees, right? And we talked about this being 360. And at 360, you're back at 0 because that's the period length, okay? So it kind of repeats like that. Cosine, a little bit different, right? So cosine, we talked about it being a horizontal shift. So cosine begins at 0, 1. So this graph here is actually going to start up here at 0, 1, okay? So if we put this one here, and then we'll talk about the horizontal shift as it goes, but it starts up here, but it kind of does the same action. It's just shifted a little bit. So now we're going to go down through here at 0, and then we're going to kind of curve around and then go back up through here. And then at 2 pi, if you notice, we're right there. So I'll kind of stop right there just to show it. So we started here at 0, 1. And then again, at pi over 2, which is 90 degrees, right? This is pi, or 180 degrees. This is 270, and this is 360, or 2 pi. Okay, so think about where we're at now, right? So this is just a difference from the sine graph. So, but you're kind of doing the same curve, you just shift it. So we'll kind of talk about that, and here's your period. So now we started up at 0, 1, and at 360, we're back at 1 for the y value, okay? So it kind of helps us with that one, right? Now, if we take a look at this graph, again, it's going to just keep going, but I'm just going to point out again that this would be your period length, right? You started here, and you went to 360, and you notice you're in the same position. So this part of the graph, similar to what we did up here, they went up, then down, then started to go back up again, is kind of our period of the graph here. Now, again, this is going to continue on this way and do the same thing. And so you might want to continue to add that in. Oops, sorry. And then it's just going to keep going in this direction here and then back up through and so on and so forth, okay? So if you look at the two graphs, really we just took this sine graph here and we just horizontally shifted it, took this piece here and just moved it over here, right? And now we started the same action, same curve. It just became the horizontal shift. That's what we talked about up here, that it's a horizontal translation. So it's the same curve process. We just shifted it back from 1, 1 to 0, 1, and away we went, okay? And there you see the sine curve, right, would start here. And so they would be together. They would kind of intertwine like so, okay? We're not going to be really concerned about that right now. So, because it's just a horizontal shift. But again, like I just pointed out, if we did this and here, if I just took the blue graph that I just did and I just shifted it over to the left, you can see that all those points would match up, right? And let's try to see if I can do that. Will it let me? Yeah, it does. See, it would kind of match up pretty good, you know, whatever. All right, so continuing on. So let's talk about some of the things and what they do with the graphs. So first, if you have the function y equals a sine b theta or y equals a cosine b theta, the a value, if we take the absolute value of a, and it's got to be the absolute value, then that's the amplitude. And then we have a maximum minimum. The a is 1/2 of the maximum minimum, okay? So when we think about that, we say, all right, whatever a is, take half of that, and that would give you your maximum point or your minimum point, okay? All right, your period is 360 degrees, right? But it's divided by the absolute value of your b value, okay? Of this value right here and right here. So it may stretch it horizontally, or it might make it more condensed, okay? Or in terms of radians, it would be 2 pi over b for that. So this is kind of going to stretch it, so how long the period is, and the amplitude is kind of about how high or low it goes. So we're thinking about that. This is like how high and how low it goes. Does the curve go? And this is how many, how long the period is, okay? All right, so for example, if we take a look at this, we would say if we have 3 sine of 4 theta, well, then we would easily be able to say that our amplitude is 3, because it's the absolute value of this, and our period would be 360 divided by 4, which would be 90 degrees. So our normal curve was 360 degrees, so this is going to condense it by quite a bit, a factor of 4. Or we could say, 2 pi divided by 4 is pi over 2, which of course is 90 degrees as well, okay? If we look at this one here, our amplitude is right here, but it would be positive 2 because remember, it's the absolute value of that. And then here would be our period length would be 360 divided by 6, so 60 degrees, so even smaller yet. And then in radians, of course, we go 2 pi divided by 6, which would be pi over 3. So that would be a much condensed curve, okay? So if you're graphing, what'll happen is if it graphs, if a is greater than 0, just something to think about, if a is greater than 0, then the graph will start the same way as its parent function. The parent function is on the first page of these notes and just be the same, start the same way. If it's negative, it will flip it over. So it's a reflection and it'll start in the opposite direction. So you'll see an example of that on our notes, but it just kind of flips it where instead of increasing, then it'll be decreasing at that moment. Okay, so let's do some examples and then see where we're at. All right, find the amplitude and period of each function, then graph, and we want to label our axes here. Now, I should point out also when we talk about the graphs that if you do these on your graphing calculator, it's not going to look kind of like this. It's not going to be going through the points because we have our values are set up like this, where our values are set up as pi over 2, pi, or 2 pi, or in terms of 90 degrees. They're still going to give you points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it won't be as good. So when you graph it, you'll get the idea of the curve, but it's going to be important to figure out this stuff here, the amplitude and the period, to see what it would look like in those cases. So that's why it says to label the axis, because we've got to know what's going on. It doesn't mean just x and y axis. It means label them with pi's and no pi's. or pies, 2 pies, 3 pies, whatever. Okay, so in this case, we know the amplitude is 1 because there's nothing in there, so it's got to be a 1. So we know that is 1, can't be 0. And we know it's positive, so it's going to be just like the parent function. But our period is a little bit different. Our period is going to be 1/3. So we're going to take our period, and that's how long it's going to take to repeat. So that's going to be 360 divided by 1/3, or 360 times 3, which comes out to 1,080 degrees. Or if you did it in radians, 2 pi divided by 1/3, or 2 pi times 3, which is going to be 6 pi. So we've actually got a much longer period. So when we graph this thing, again, we're going to start at 0, 0, and the amplitude is 1. So what that means is that that's how high it's going to get to. It's going to go up 1, and then the lowest it'll go is -1. So +1, -1. So we need those there. Now, as I'm just drawing, I'm going to try to do them as close as I can, or as the same distance, but it might be a little bit off, which might affect my curve, but I'm just doing this freehand, so just bear with me. Okay, so if I go through here and I say that this is pi, then this would be 2 pi, and then this would be 3 pi, and we'd have 4 pi, 5 pi, and I need one more over here, 6 pi, okay? Because that's the length of the period. So now I know that what's going to happen is it's going to start here at 0, 0, because it's a sine curve, start at 0, 0, but it's not going to restart until we get to 6 pi. So we'll be increasing this way, so it's coming from down here, and we're going to go up, and it's going to really stretch out now, and it gets to the point where it's coming down here. Sorry. It's going to go up here, and then it's going to start to curve down, and then it's going to come back through 3 pi, because I'm just thinking about those degrees, and it's going to work its way back and eventually come back up through at 6 pi. Okay? So it really stretched out that original sine curve. Made it 6 pi long instead of 2 pi. Normally, right? Normally, it's like this. It goes up here, down here, and here. So we're taking the same curve, really just stretching it out. Okay? All right. So now we've got the next one, cosine. Now we do have an amplitude. Our amplitude here is 1/3. The period hasn't changed. So I know the period is still 360 degrees, or 2 pi. So that hasn't changed at all. So what's going to happen with the amplitude, though, is going to tell me that's how high it's going to raise or lower. So this one's only going to go up. If we have 1 here and -1 here, our amplitude is going to keep this pretty low. It's going to be at 1/3, and it's going to be at -1/3. That's how high and low the curve is going to go. We still know our period is going to be the same. And I can keep going with these things as we go. But really, I just need, I'm going to put pi up here, and I'm going to put 2 pi here, just because I know the curve. In this case, we start a little bit higher. We don't start at 0, 1 here. We're actually going to start at the 1/3 part. And then we work our way down. And then we stay at that 1/3. We come back up. And then we'll get to right about here. And that's our period. And then, of course, it's going to keep doing that as it works our way through on and on and on. Okay, so the graph looks the same as the cosine graph. It's just not as tall. As you know, the regular cosine graph started up here and went like this, okay? But it just didn't go as high, okay? So here we go, 2 more. All right, so this one, let's take a look. We've got amplitude of the absolute value of -2 is 2. So now I'm going to go a little bit higher, and our period is going to be 360 divided by 4, right? Because of this value right there. So that's going to be 90 degrees. So in this case, we're going to have a much smaller And then if we take it in terms of radians, pi over 2. So our period is going to be much, much smaller in this case. So that means we're going to be moving, and our amplitude is a little higher. So when we graph this, if I think there's 1, there's 2. Again, it's a sine curve, so it's going to start here. If I do this, if I'm looking at the graph, so if I go, let's keep the same ones and go pi over 2. This is pi. 2 pi would be over here, right? And keep going. This one's going to go up and down, but it's also going to have a shorter period. So all this stuff is going to happen within that first half pi. But it's going to go, and the other thing to point out is this negative sign. A is negative. So that's going to kind of flip it. So normally with the sine curve, you start here and you go this way. In this case, we've actually flipped it. It's going to be decreasing and going this way. Okay. And it's going to be very steep. And I probably should have stretched this out a little bit more. But just to get the idea, I'm going to keep it this way because it's going to be very steep because it's going to go straight down here. And remember, its period is pi over 2. So it's got to go down. It's going to come all the way down here. It's going to go back up here. And then it's going to come back down to there. And that's how, that's one period of it. Okay. And then it's going to continue to do that. So you're going to have a graph that's going to have a lot of spikes. And it's going to be looking like this. Notice how it's condensed as it goes through. Okay. And this negative value, I flipped it around. Normally we start going up. Now we're going down. Okay. And then finally, one more. In this case, cosine graph. Okay. Our period is our amplitude and our period. Amplitude is 1/2. It's positive, so it's going to go the same way as the parent function. But now I know that it's going to start if here's 1 and here's -1. Here's my 1/2 and here's my -1/2. That's how high and low the curve is going to go. And my period here is going to be 360 divided by 3 because of that 3. So every 120 degrees or 2 pi over 3. Okay. So now what you're going to have is a little bit smaller. It's not going to be as steep, but it's going to start up here. I should label again. I'm just going to kind of make that half pi, pi, and then 2 pi. Okay, so 2/3 pi is kind of going to be right in here. So now I've got to have my period go this way. It's going to go through, it's going to start up here, and it's going to drop down here, and it's going to be a little bit different because it's got to be a slow roller, and eventually going to come back up, and then here is where it's going to stop. And it's going to keep doing that throughout as we just keep the curve going. Okay, so there's a general idea on how to graph these things using amplitude and period, and we'll do some practicing with it as we go. Okay, that's not bad, 23 minutes with all this stuff. All right, so we'll practice, have questions ready, and we'll be fine with this. Have a great day. Great day.